So here's a triangle, and I think we normally label the angles A, B, and C, where the angles are these measurements. I'm kind of supposing that there's some other geometry class maybe that you took in high school that would have talked about angles and whatnot, but the basic idea of an angle is that I have this starting line that's flat, it's horizontal, and then I curve myself up a certain amount above this, and then I draw a second line that I'm kind of pushing along, and this piece right here is my angle. Angles can be measured in a variety of ways. We usually use degrees. And so we have some of maybe the usual angle measurements. So if I have something that's making this, we call this a right angle, and we would say this angle is a 90-degree angle. If I have this right here, this is 180 degrees. And if I start here and go all the way around and get right back to where I began from, we would say 360 degrees. That happened. And so here's the main two types of angles we have. If I have anything that's inside this area here, that's less than 90 degrees, we'd call that an acute angle. And if I go further than 90 degrees, all the angles that are 90 degrees all the way up to 360 degrees, so I guess this would be the 0 degrees up to just a little bit less than 90 degrees, be an acute angle. These ones that are bigger is called obtuse angle. And when you bend three lines together to form a triangle, here's a fact. The sum of A angle plus B plus C has to equal 180 degrees. This is always true for every triangle, always. Some other geometry facts that I've got going for me. If I have a flat line here, that this one kind of is, and then I draw some other sort of line across it, it doesn't matter what I do. This angle and this angle is the same. When I have similar angles, I draw the same sort of lines through them, and this angle here and this angle here is the same. I draw two lines here to show that this angle and this angle over here are the same, but they might be different from this guy and this guy. They're going to be possibly different. So I've got this angle fact as well. When I'm talking about some different types of triangles, I've got acute triangles. And acute triangles, well, all of their angles are acute. None of the angles are bigger than 90 degrees. On the other hand, I could have a right triangle, and we'll talk about these quite a bit, using the triangle shape as an abbreviation for triangle, and that's pretty common. Right triangles have one of their angles as a 90-degree angle. And then, of course, we also have the last type of triangle, obtuse triangles. These ones have one of their angles is bigger than 90 degrees. For each one of these, all of the three angles still add up to 180 degrees. It's just sort of bent in different shapes. So that's how you measure or talk about triangles based on their angles. You can also talk about them based on their sides. And if a triangle has two sides that are the same, and a third side that's different, that's called an isosceles triangle. If it's got three sides, which they all do, and all three sides are the same, that's going to be called an equilateral triangle. Equilateral. The equi meaning equal. A fact about equilateral triangles is that if you look at them, another fact about triangles is that the angles that are across from any given side to relate somewhat to that side, which means that since this angle is the angle that makes enough distance between this bottom line and this top line to swipe out this much of a length, this angle and this side have a sort of ratio relationship. And what that means is since each one of these angles is swooping out the exact same length, each one of these angles is the same. And so if you take 180 and divide it by 3, that gives you 60 degrees. I have this little degree mark here that I do, and just like when we were doing number systems and I had the number 101 and I could put either base 2 or 101 base 10, and this would have given me very different numbers, so too with, and it was very important in the binary section that I made sure to label my base. It's important here to make sure that you label your degrees as this little degree symbol with your angle. You don't want to just write 60. It's important to talk about the degrees that are going on. And then lastly, in terms of the sides, we can have a scaling triangle. And a scaling triangle is one where all the sides are different lengths. So a great many of our right triangles are also scaling. I think the main part that we have in this section is if I've got myself a right triangle and I've labeled my sides A, B, and C, where I have my angles, then the capital letters are my angles, and then I use lowercase letters for the side that's opposite that angle. Just like I said here, this is the angle that lets me swoop up just enough distance between these two parts to encompass this whole side here between them. So this angle right here, this 90 degrees that's going on at this point, is just the correct amount to get myself this side of length C. So this would be my side of length A, and this side would be my side of length B. We have some words for these things. These are called legs, and this right here is called the hypotenuse. It's the longest side, because if you have 180 degrees as your total, and we get rid of the 90 degrees, that's this part right here, I only have 90 degrees left, and that 90 degrees that's left has to get split up between the A angle and the B angle. And that means that each of these angles is smaller than this one, and the largest angle is going to be opposite the longest side of the triangle. We have this formula, and this is called the Pythagorean theorem. And maybe you remember from our deductive logic section that talks about what a theorem is. And so a theorem is not just something that might be true, it is true, and it's based on all the logic that we've done before. So all this fact about different degrees and all these different angles and stuff that we've been doing all build up to this fact. If I take the length of the A leg and square it, and then take the length of the B leg and square that, this is going to equal the length of the C leg squared. Sometimes I think maybe we write it C squared equals A squared plus B squared. I don't know which order is your favorite, but this is true. So anytime you've got some different lengths, you've got some common things. So as soon as I have this right here, once I know two of these angle sides, I can solve for the other. And it doesn't matter which one we do. So maybe if I do this length here is 16, and this one right here, I don't know, let's actually do 3 and 4. I think this is going to be the 3, 4, 5 triangle that's super popular. So I don't know what C is, so I say C squared is equal to A squared plus B squared. This one's B, this one's A, so I have 3 squared plus 4 squared. This is 9 plus 16. C squared is equal to 25. I take the square root of the left side of my equation, so I take the square root of the right side. So C is going to be either plus or minus 5. Because remember, minus 5 times minus 5 is also positive 25. But we're talking about lengths here, so only the 5 one makes sense. So that gives me that answer right there for my different lengths.